Hi there. For the last video in this chapter, we're going to actually use the percent abundance and the mass of each isotope to calculate the average atomic mass. So this is the number that is on the periodic table, and it represents the weighted average of all the isotopes of that element that exist in nature. So the graphic that you have on the page in front of you shows how we calculated the average atomic mass of chlorine. So chlorine has two isotopes. This guy is chlorine 35, and chlorine 35 means that it has 17 protons and 18 neutrons, and chlorine 37, 17 protons and 20 neutrons. And so therefore they would have different masses. Those isotopes would have different masses. But they also have different percent abundances. There's the chlorine 37 exists less frequently in nature. So therefore, it should count less towards the average atomic mass. And if you look at the calculations that are shown here, they calculate something that's called the mass contribution. The mass contribution is basically taking the mass of the isotope and multiplying it by the percent abundance changed into a decimal form. And then once you add those up, you get your final answer, which is the average atomic mass. And these questions are really easy to do because it's a formula. You plug in the numbers and you solve, but it's also really great because you can check your answers, because the answer should be, if you're calculating the average atomic mass, the number from the periodic table. So the general formula here, take a look at how we calculated the mass contribution of each of these, and then we added them up. So what is the mass contribution? The mass contribution would be the mass of the isotope, and then you multiply that by the percent abundance. But remember, when we use percentages mathematically, we need to change them into decimals, which means we divide by 100. And then we would add that to how the other isotope, or the other 3%, the other 3 isotopes, 4 isotopes, however many isotopes there are, we just keep adding up those mass contributions. So this might be, the mass of the other isotope. And again, you take the percent abundance and you divide that by 100. And then you add them together. The unit for these will always be that AMU, that atomic mass unit. So let's do 2 practice problems here. Whenever we do a practice problem, remember a couple things. Number 1, formula, plug in the numbers, and then check your answer. And when we check our answer, we're going to check for significant figures and units. And if you feel like you have this and you want to give this practice problem a try, pause the video, then do the problem, then check your answers. So the practice problem says, given the data in the table, calculate the atomic mass of an unknown element. Then identify the unknown element. So that means looking on a periodic table and figuring out which element has that average atomic mass. So there's 2 isotopes, an isotope with a mass number of 6 and an isotope with a mass number of 7. Because a proton, neutron don't weigh exactly 1 AMU, the mass of the isotopes is a decimal, a little bit off. And then here's our percent abundance. So the average atomic mass, right? We always write the formula. The percent abundance divided by 100 times the mass of the isotope. I know that's a different order than I wrote it on the previous page, but remember, multiplication order doesn't matter. So the percent abundance of the first isotope is 7.59. So you can write 7.59 over 100, or you can do that in your head. If you do that in your head, just be careful, because students often will get that incorrect. And then the mass of that isotope is 6.015. AMU. The mass, the percent abundance of the other isotope is 92%, or as a decimal, 0.9241, times the mass 7.016 AMU. Okay, when we multiply this out, the first multiplication comes out to be a very small number, 0.456 AMU, and the other one is 6.483 AMU for our final answer of 6.94 AMU. When I'm actually doing this in my calculator, I'm not rounding in between each step. That's one thing that we do in chemistry is we don't round until the very end. So I was using the whole number that has infinite number of decimal places in my calculator. And then before every answer or before we call a question done, we need to check for our answer. Does our answer have units? Yep. Does our answer have the right number of significant figures? So the first step that we did here was multiplication. That number has 3 significant figures. Every other number that we have here has 4. So I just say that my answer should have 3 significant figures, 6.94. You don't really, I'm not going to be too picky with significant figures in this particular problems because then we do addition. And you could also carry this out to 4 significant figures and that would be okay too. The question actually, remember, circle the do, underline the clue. The question actually asks us to identify the unknown element. So I look on a periodic table, and what element on the periodic table has an average atomic mass of 6.94? Well, that's lithium. So my answer is actually lithium. The next question, boron has 2 naturally occurring isotopes, boron 10, and then there's the data that corresponds to that, and boron 11. Calculate the average atomic mass. So circle the do and underline the clue. I didn't do that on the last problem. That's a good habit to always get into. And then I write the formula. Average atomic mass is equal to the percent abundance over 100 times the mass of the isotope. And then I just put ... with an addition sign so that I know, and I do that for every single isotope. So the first one, so 0.198 is 19.8% divided by 100 times 10.013 AMU plus 0.802 times 11.009 AMU. If you don't show this next step, if you just plug this into your calculator, that's fine. Because remember, if we're using this structure to answer those problems, I just need a formula, I show the numbers plugged in, and the next thing I need is the answer. It does come out to be a percent contribution or a contribution of 1.98, and this is 8.829. Of course, those are both AMU. We try to get into the habit of always writing down our units. 10.8 AMU. Again, I'm using the 3 significant figures that are coming from, oh, these are not 4. The 3 significant figures that were coming from the percent. These guys have 5 significant figures actually. So my answer has 3 and I have the units down there. The last page of this, because we're at the end of the chapter, is really summarizing the whole chapter. So there's 3 different isotope notations of 3 different isotopes of potassium, americium, and xenon. And using a periodic table, you will definitely need to use a periodic table for some of this information. I want you just to fill out the element name, the atomic number, the mass number, the number of protons, number of neutrons, number of electrons, and average atomic mass, which you're going to need to find from the periodic table. We'll check this when we're in class next time. Thanks.